Hello everyone, welcome to MindMatrix. So in this video, we will be solving GATE previous year questions of 2023 from compiler design subject. Okay, so let's start. Before starting, let me introduce myself. My name is Anshul Sharma. I'm upcoming software engineer at Juniper Networks. Currently, I'm pursuing M.Tech in computer science from IIT Kanpur. I have more than 2 years of teaching experience, mentored more than 1,000 students as of now, and I have the expertise in computer science and data science subjects. I secured All India rank 294 in GATE Computer Science, cleared ISRO NIC NELET exam, also got selected as Administrative Officer at AIC. So you can join our doubt discussion telegram group. This is the QR code. You can scan and you can join where you can ask your doubts, right? And we will be posting all the video updates there in our group. Apart from that, we are also going to post the PDFs of all the lectures that we are conducting on YouTube. Okay, so you can join and you can make the proper utilization of this group. So let's start with our first question that was asked in GATE 2023 from compiler design subject. Okay, so let's read the question first. Consider the following statements regarding the front end and back end of the compiler. So we know that we have front end and back end of a compiler. So let's read the statements. There are three statements given to us and we need to read all the statements first. So statement S1 is saying the front end includes phases that are independent of the target hardware. Okay, so basically let me explain you. We have lexical analysis phase, the first phase of the compiler. Then we have syntax analysis phase. Then we have semantic analysis phase. Okay, then we have ICG, that is intermediate code generation. Then we have the code optimization phase, and then we have finally target code generation phase. So these are the phases, various phases of the compiler. And if we talk about this, so this is called as the front end of the compiler. So front end of the compiler generates the intermediate code. Okay, so this generates the intermediate code, and this is the back end of the compiler. We also called this front end as the analysis phase. Okay, and this as the synthesis phase. Right, now we need to carefully see this. Let me write here also analysis phase and synthesis phase. Right, so we have these two front end and back end phases of the compiler. Now this statement S1 is saying the front end includes phases that are independent of the target hardware. So this statement is definitely true, because your front end does not depend upon the target hardware. It is independent of the target hardware. Your backend depends on the target hardware. That's why here we have the target code generation based on your machine, based on the architecture that you have. Based on that, you have this backend designed for it. Okay, so your front end generates the intermediate code, and then intermediate code will be interpreted, and the optimizations will be done, and finally we get the target code generation, that is the assembly code that is going to be generated by this backend of the compiler, which depends on your machine, that is which depends on the architecture. Clear? So the backend includes phases that are specific to the target hardware. Yes, this is also true, as I explained you now. Statement S3 is saying the backend includes phases that are specific to the programming language used in the source code. This statement is false. Why is it false? Because your backend is independent. Your backend basically depends on the target hardware, not on the programming language that you are using in the source code. Your front end converts the source code into the intermediate code. Okay, that is going to be used by the backend of the compiler. So your backend does not depend on the programming language. Clear? So that's why this third statement, it is false here. So we have to identify the correct option here. So S1 and S2 are true. So we can say option B is the correct answer here. Only S1 and S2 are true here. Clear? Very simple question and theoretical question. If you have attended the lectures properly, if you have studied compiler properly, you will be able to easily answer this question. Let's proceed to the next question now. So second question, consider the following program So we have this program given to us where we have a main function, we have a function f1, we have a function f2 which is taking an integer argument, okay, and we have a function f3 as well. Now question saying which one of the following options represents the activation tree corresponding to the main function. So as we know, whenever we call a function, a certain basically a activation function is called. The space is going to allocate it into the stack. So here it is talking about the activation tree that is corresponding to the main function. Okay, so first of all, as you know, the execution starts from the main function, right? Now if you seek the code carefully, we have a main function, then we are calling function f1, then we are calling function f2 which is taking the integer argument as 2, then we are calling the function f3 and then it is returning 0, right? So first of all, function f1 is called through main function, function f1 is called. Now here we are in the function f1, it is basically returning 1, that's all, right? Then we have function f2 where it is taking the integer 2 as the argument. So here we are giving 2 as the input argument in the function f2, and then here we are calling function f3, right? Now if x is equal to 1, then we are going to execute this statement, else we are going to execute this statement. But here as we know x is equal to 2 initially, so in that case else statement will be executed. This if statement is not going to be executed in the first run, okay? And then we have this definition of f3. So what should be the activation tree corresponding to the main function? If you see option 1 here, option A here, we have a main function, fine. Main function is calling f1, f2, f3. Yes, f1, f2 and f3. All three functions are being called by the main function one by one. In case of f2, it is taking integer 2 as the input. So yes, we are going to give 2 as the input. And then when we are calling f2, we are calling f3 as well. So for f2 we are calling f3. Yes, that is also correct. As the value of x is equal to 2 initially, so we are executing basically this else statement where it is x multiply f2 of x minus 1. That means we are again going to call f2 function here. So yes, we are calling again the f2 function as the value of x is equal to 2 initially. And then this statement, if you see here, so basically it is going to take x twice into f2 of 2 minus 1, that is 1. So again we are going to call this f2 of 1. So on f2 of 1 we are going to call this function, again it is going to call f3. Yes, it is calling f3. And now this time as the value of x is equal to 1, so this time if statement is going to execute, not the else statement, and this time we are calling f1 function. So yes, we are calling f1 function, and then this terminates. So for f3 it is basically just returning 5. So yes, it is going to return 5. And as we can see, based on the given program, option A is the correct answer for this question. But still we are going to see other options as well, why they are not correct. So here we are calling main function, fine. We are calling f1, f2, f3, both, yes. Now in case of f2, x value 2, we are calling f3, that is also correct. But here we are not executing this if statement when x value is equal to 2. So according to this activation tree, f2 is directly calling f1. So this is incorrect. Due to this one, it is incorrect. Clear? Option C, it is calling main function, then f1, but it is not mentioning the f2 and f3 calling, right? So that's why option C is clearly it is incorrect. What about option D? Here we have main, f1, f2, f3 is being called. f2 is calling f3, yes, okay. Then f2, yes, because x value 2, so that is also correct. But f2 is not in the first run, it is not going to call f1, okay, because the value of x is equal to 2. So due to this one, it is also incorrect. So option A is the correct answer for this question. Very simple question. Let's proceed to the next one now. So here we have question number 3, that is from GATE CS 2023. Consider the control flow graph shown. So we have a control flow graph here that is being given to us, okay. Which one of the following choices correctly lists the set of live variables at the exit point of each basic block? Now here we need to find the set of live variables where at the exit point of each basic block. So we have if you see this figure, we have four basic block. What are basic block? So there is no jump instruction. The set of statements are present in a block where there is no jump instruction and there is no halt instruction. So it is going to execute sequentially. We call that set of statement as one basic block. That is the definition of basic block. So we have here B1, B2, B3 and B4. So we have four basic blocks. And as per the question, we need to find the set of live variables at the exit point of each basic block. That means we need to find live variables here. We need to find live variables here, here as well, and here as well, at the exit point of each basic block. Okay. Now the question says set of live variables. What are live variables? So live variables, basically, let me explain you through one example here. That will be very easy for you to understand. Let's say we have one basic block here and I'm writing x is equal to y plus 4. Let's say this is one basic block here. Now, if I want to find the basic block here, so I'm going to represent that as a out of B block. So here I'm going to mention the basic blocks here. So if you see carefully, in order to find the basic block, we can go from downwards to upward. So bottom to top approach we are going to take in order to find the live variables. So as of now, just for this example, we have only one basic block. So let's understand through this one. If I see here, do we have any live variable here? I mean, below this basic block, do we have anything which is live? No. So basically we have an empty set here. Got it? We have an empty set here. Now, if I talk about the entry point, that means the in of this basic block B. Now, what are the set of live variables? What set of live variables present here at the input of this block? So we can say y is going to be the live variable because we are reading its value before we are updating it. Again, I'm repeating. We can say y is going to be the live variable at the input of this basic block because we are reading the value of y before we are updating it. Clear? So we can say y is our live variable. Now let's take one more example. If I'm writing x is equal to x plus 1. Again, at the exit of this basic block, we don't have anything as the live variable. If I talk about the entry point of this basic block, can we say x is our live variable at the entry point of this basic block? Let's say B7. Yes, we can say x is our live variable here. How we can say it? Because first we are reading the value of x and then we are updating it. First we are reading the value of x and then we are updating it. So we can say at the entry point of this basic block, x is our live variable. I hope you get the concept. Okay, I hope it is clear to you. Now let me take one more example just to make more clarity when we have, let's say, two basic blocks. Because I'm explaining all these examples first before solving the question, so that if any one of you is learning this concept of live variables for the first time, so you should be able to understand and grasp the concept behind live variables. Then only you will be able to understand how to solve this question. Okay, so that's why I'm taking more examples. Let's say we have this one basic block. I'm just writing BM and let's say it is BN. You can substitute any number also. So BM and BN. Let's say I'm writing here x is equal to x plus y. Okay, so we have these two basic blocks. So or you can consider this as the one control flow graph given to us. Okay, and here I'm writing, let's say a is equal to a plus 1. Okay, now if I need to find the basic block here, so here it is empty. It is empty at the exit of this basic block Bn. Clear? What about the in of this? So in of this basic block, that means at the entry point, what are the live variables we have? Can I say x is our live variable? Can I say x is our live variable here? Yes, we can say, because first we are reading the value of x and then we are updating it. So first we are reading the value of x, then we are updating it. So clearly we can say x is our live variable here. Do we have y as a live variable here? Yes, y is also a live variable because we are reading the value of y, right? And there is no updation. So simply we can say y is also our live variable at the entry point of this second basic block. Clear? What about the out of this basic block? Now carefully understand one more concept. So if we have, let's say, these two basic blocks in a control flow graph, whatever we have here as the in, that is going to be the same as the out. Again, I'm repeating, whatever we have in of this basic block, that is going to be the out of this basic block, because there is nothing in between. There is nothing in between these two basic blocks. So whatever is in, that means it is coming from the upper basic block. So we can clearly write x comma y is going to be the out of this BM basic block. Clear? Because there is no updation happening here. Understand the intuition and the concept behind it. There is no updation happening between these basic blocks. So that is why whatever is the in of this basic block, obviously it is going to be the out of this above basic block, upper basic block. Clear? So x comma y will also be there as the out of the set of live variables present at the exit point of this BM basic block. Clear? Now, what about the in of this one? This BM basic block. So whatever is coming from the lower one, x comma y, here we are not making any updation in x or y. So clearly we can write xy will definitely be there as the live variable. What about else? Here if you see this basic block, yes, a is also going to be our basic this live variable. A is also going to be our live variable because first we are reading the value of a and then we are updating it. So that's why it is also a live variable. If you are updating the value first before reading it, then it is not going to be the live variable for that particular basic block. Clear? If you are updating first, then it is not going to be live variable. If you are reading first before updating it, it is going to be the live variable. Clear? I hope it is clear, the concept of live variable. Now in this question, if you see, we have four basic blocks, B1, B2, B3 and B4, and there is a loop as well present. There is a loop also present here. So when there is a loop, we have to make multiple backward iterations. We have to make multiple backward iterations in order to find the set of live variables present at the exit of each basic block. And how many iterations we are going to make until it stops updating further, until we don't get any new live variable. So till that point we need to make the multiple backward iterations. I will explain you how to solve this question. Just to understand, when there is a loop, we have to make multiple backward iterations. The concept is same, the out and in, the concept is exactly the same that we are going to use in this question to solve. Okay. So just carefully observe how we are going to find the basic block here. So let me just erase this one. Okay, now let's solve this question. So, so we need to find the set of live variables at the exit of each basic block. So initially, as I told you, we have to go from bottom to top. We have to go from bottom to top. So at the exit point here, if I say what are the live variables present, just don't consider loop as of now. Just in the first iteration, what you can see. Do we have anything? If we see below B4, do we have anything? No, it is exit, right? So we can say, okay, there is no set of live variable present at the exit of B4 as of now in the first iteration. Clear? What about in? What about the in of B4? Do we have any live variable? Here it is written I is equal to A plus 1. Can I say A is my live variable? Yes, because we are reading the value of A and there is no updation happening. So clearly we can say A is our live variable here as of now. Do we have I as our live variable? No, because we are updating the value and we are not reading it. So clearly we can say directly first, we have to see whether we are first updating or first reading. Here we are reading, here we are updating first the value of I. So I is not our live variable here. Clear so far? Now, this is in, so definitely out For this one, out is also going to be A here. Out is also going to be A here. Similarly, out also going to be A here. That means the exit of B3 and B4 both are going to have A here. Due to this B4, because there is an arrow from B3 to B4, there is an arrow from B2 to B4. So due to this B4, the entry, the set of live variables that are present here at the entry of B4, we are going to have the same set of live variables present at the exit of B2 and exit of B3, because there is a path from B3 to B4 and there is a path from B2 to B4. Clear? What about the entry of B3? Do we have any live variable here? If you see from the downwards, we are getting A, but here we are updating the value of A. We are updating the value of A. So clearly we can say now A, at this point, A is not our live variable because we are updating it before reading it. Clear? So here we don't have any live variable. So if in is blank, exactly we are going to get that here. That means just A is going to be there because A we are getting from B4, not from B3. So this is so far we have the set of live variables. What about in of B2? What about in of B2? A is coming from downwards. So yes, and here we are not updating A in any of the statements. So A will be there for sure. A will be there for sure. I is also going to be our live variable because first we are reading the value of I and then we are updating it. So I is going to be there. J is also going to be there as our live variable. Clear? If this is the in, definitely the same thing we are going to have as the out also for B1. At the exit point of B1, the same set of live variables we will be having Aij. What about the in of B1? Though we don't need to find it because there is no loop from there, and we are just interested to find the exit, the live variable, set of live variables at the exit point, but still let's find it out just to to gain more clarity. Now here if you see, we are updating the value of A, so definitely A here, it is not going to be the live variable because we are updating the value of A. What about I? We are also updating the value of I before reading it, so I is also not going to be live variable here. What about J? Same case with J. We are also updating the value of J before reading it. Clear? So Aij, they are not going to be present here as the set of live variables. What about M? Yes, M is going to be there as the live variable. N also is going to be there as a live variable because first we are reading the value of M and N before even updating it, and here we are not updating as well. So M comma N is going to be our live variable. This is the scenario in case of first iteration. This is the scenario in case of first iteration. So now let me write here the set of live variables that we got after first iteration, and then further we are going to make, do the second iteration that I told you, the backward iteration, multiple backward iterations we need to make. Right, here we have A. Clear? And here at the exit of this we have Aij. Clear? So that's all we have here, and here we have the empty braces. Fine. Now let's do the second iteration. Why we are making multiple backward iteration? Because there is a loop now. From B4 to B2 there is a loop. So as I told you, if we have two basic block like this, so as I told you, the in of this is going to be the same as out of this, correct? The in, that means the set of live variables present at the entry point of this basic block, is going to be the same set of live variables present at the exit point of this block in this scenario. So here also if you see, the in of this is what? This is the in of B2. This is the in of B2, and this is what? This is the out of B4. So in case of this loop, when we make the multiple, when we make backward iteration, can we say out of B4 is going to be the in of B2? We have to take the union of that. whatever is there present, and whatever we are getting from there, the in of b2, we have to we have to take the union of this. We have to make the union of all the live variables. So here we have empty, so no need to worry about, but here we are getting aij as the in of b2. So can I say empty set and union of aij? So here the final, here we can say that the set of live variables is going to be a, I and j. Can I say this? Yes. Can I say this? Yes. So now we have out of B4 as aij. So let me just erase this one. Fine. Now we have aij as the out of this. Now let's go upward, further upward. So here we are getting aij from the downwards. Now what about in of B4? I is not going to be there because we are updating the value of I, right? A, definitely A is there. What about J? Yes, J is also going to be there. J is also going to be there. Okay, now it is A comma J. Clear? Now A comma J, so I can say J is also present here. What about here? I can say here A, it is going to be A comma J here as well, because whatever is in of the below basic block, that is going to be the out of the upper basic block. So aij is there, aij is there. What about this one, in of b3? A is not going to be there because we are updating the value of A before even reading it. So A is not going to be our live variable, but J is definitely J is present here as the in. Definitely J is present here as the in. What about this one? So we have to take, whenever there is two paths, we have to take the union. So J comma AJ, that is going to be AJ only, right? So there is no change here. What about in of this one? That means is there any change here that we need to find? In of B2. So A, we are not making any updation in A. So A is definitely going to be there. J, yes, J is also there because we are first reading the value of J, then we are updating it. So J is our live variable. Same case with I also. So there is no change here in of B2. Aij is going to be the live variable here. There is no change here. In of B2 is there. So out of B1 is aij only because there is no updation happening between B1 and B2. Clear? So aij is there and there is no change here as well. So this is the second iteration. Let's make the third iteration in this case and in this figure only. In third iteration, make another backward iteration here. We have to make multiple backward iteration till we get the same set of live variables. So let's make one more backward iteration, aij. Union of aij is going to be aij only. So there is no change here. There is no change here as well. A comma j is going to be there. Clear? And here a comma j is there, a comma j is there. Again no change because we are getting the same thing. So there is no change again in the third iteration. So now we can stop. We can stop when there are no changes further happening in the set of live variables at every basic block. Clear? At every basic block, if there are no changes happening in the live variable set of live variables present, then we can stop. So this is what we are getting. Now let's see the options here. So first let me write here for B1, at the exit point of B1, what are our live variables? At the exit point of B1, what do we have? Aij we have as the set of live variables present at the exit of B1. What about the exit of B2? We have a comma j. What about B3? Same, we have a comma j. You can see here we have a comma j as the set of live variables. And what about B4? We have aij as the set of live variables here. So aij, aj and aij. So let's match with the options. So definitely option A is incorrect. Option B is also incorrect because in B1 we have aij. In option C we have B1 aij. Here it is AIJ again. No, in B2 we have AJ only, and this is also incorrect. So option C is also incorrect. What about option D? We have AIJ in B1. Yes, you can compare. We have AIJ in B1, right? In B2 we have AJ, in B3 we have AJ. So in B2 we have AJ, in B3 we have AJ, and B4 also we have AIJ. So option D is the correct answer for this question. So I hope this question is clear to you. The concept of live variables is clear to you, and now you will be able to solve any question based on live variable. I can make sure this. After learning this concept, you can clearly solve any question based on live variable now. Okay, so let's proceed to the last question that was asked in GATE CS 2023 from this subject compiler design. So so this question is based on SDT, syntax directed translation. So let's understand this question first. Consider the syntax directed translation given by the following grammar and semantic rules. Okay, so we have this grammar given to us, and the its corresponding translations are also, or you can say semantic rules are also given to us. Here NIF and B are non-terminals. This complete one is SDT. Okay, so here NIF and B are non-terminals. N is the starting non-terminal, and hash 0 and 1 are lexical tokens corresponding to input letters this respectively. Clear? X dot value denotes the synthesized attribute, a numerical value, a numerical value associated with the non-terminal X dot L1, I1, and F1 denote occurrences of I and F on the right hand side of a production respectively. Clear? So this is just explaining what do we have as the value of, if it is a value is 0, so that is going to, we are going to assign that to, particular non-terminal. If it is 1, we are going to assign that. So that's what it is explaining for the token 0 and 1. 0 dot value is equal to 0, 1 dot value is equal to 1. Now the question says the value computed by the translation scheme for the input string. Now this is the input string given to us, and we need to find the value that is going to be computed by this entire translation scheme, and that is also has to be rounded off to 3 decimal places. So let's solve this question now. Here we have these SDT given, and the input string is 10 hash 011. So we have 10 hash 011. This is what do we have as the input string. So for this given input string, we need to make the tree first. As we can see, hash is there. So definitely first we have to start with the root node, that is n, right? And then we have I here, hash here, and here we have f. Now on the left of hash we have two values here, 1 and 0. So we need to make the tree in such a way so that we can get these two values. And on the right of hash we have 0 1 1. We have 3 values here, and we have to make the tree in such a way that we get 3 values here. So we have to see which given grammar we can use here. So from I it is I1B, right? And from I it is B also. But from B we can get just one value. So that means we have to use this one. So it is going to be I1 and it is going to be B. You don't have to write I1, or you can just write I also. That is also fine. It is just to mention that it is on the right of this. Clear? That is going to be derived by I. That's all. So we can just simply write here as I. Fine. Now if you see, from I we can get B, and from B we are getting the value 0, either 0 or 1. So here I need 0 only, because we have 0 here, and from I want to generate 1. So from I to B we can write B here, right? And from B we can get 1 here. Clear? This is what we have on the left side of hash. On the right side of hash we need 0 1 1. So from F we can get BF, or we can get B, right? But from B we can get just one value. So we need to have here B, and here we need to have here F. But we need 3 values, so again we are going to have B, and again we are going to have F here. Now we can get 3 values here. From B we can get 0, from B we can get 1, and from F we can get B, and from B we can get 1. So let me just highlight the values using different colors. so that you can clearly see it. So this is what we are getting. 1 0 hash is there and 0 double 1. Clear? So this is the tree we have. Now we just have to use these translations, these rules, and based on it we are going to compute the value that we are going to find at the root node. That means the value that it is being computed by this given SDT. Okay, so let's do it. So here yes, so from, if we start from this one, b to 1, b is generating 1, that means this one. So we are just, what we are doing here, we are just assigning the value to b. So we are just assigning the value to b. We can say here b dot value is 1, so we can clearly write that it is 1. It is having the value 1. Just in short we can write it is having the value 1. Similarly here it is having the value 0, here it is having the value 0, here it is 1, and here it is 1. Now I is generating b, that means this one. So it is simply just assigning whatever the value of b, we are assigning to the value of I. So here we are assigning the value of I here, so it is 1 only. Clear? And here it is I generates IB, I to IB. So this is what we are going to use here. And what it is doing, twice of I value plus B value. So twice of I value plus B value. So we can say twice of I value is 1 here plus B value, that is 0 here. So what do we get? 2 into 1 plus 0, that is going to give us 2 only. That is going to give us 2 only. Clear? So this is the value we have here now at this node I. Now let's see here. We have f to b. So it is just getting the half of b value. Whatever is the value of b, we are taking half of it and we are assigning it to f. So we can clearly say that it is going to get 1 by 2. Half of 1, that is 1 by 2. F to bf. F to bf, this translation we are going to use, and it is saying half of b value plus f1 value. So half of b value, that is 1, plus f1 value, that is 1 by 2. So what are we going to get? This is going to be 3 by 2. 3 by 2 into 1 by 2, that is going to give us 3 by 4. That is going to give us 3 by 4. This is the value we have at this node f. Again, f drives bf, so we are going to use again this translation. So here also we are going to get half of b value, which is 0 here, plus f value, that is 3 by 4. And we are going to get 3 by 8. Clear? Now n drives I, hash, and f. That means finally we are going to use this translation here, I plus f value. So it is nothing but 2 plus 3 by 8. And this is going to give us 3 by 8 is nothing but 0.375. So 2 plus 0.375 is going to give us 2.375. This is going to be the answer. This is going to be the value that is being computed by this given SDT. I hope it is clear. So, and the question is saying rounded off to 3 decimal places, and we are getting that in 3 decimal places. So we can simply write answer is 2.375. That is the answer. Clear? So in this way we can solve these SDT based questions. So that's all from a compiler design. So we have solved all the questions that were asked in GATE CS 2023 exam from this compiler design subject. Now you can join our MindMatrix YouTube channel. The link is also given in the description of this video or of every video on our YouTube channel. The link of Telegram doubt discussion group is also given in our description and on our main channel, MindMatrix. You can like this video, share with your friends, those who are going to appear for GATE 2024 and those who are going to prepare for GATE 2025. And subscribe to our channel MindMatrix and share with all your friends in all your WhatsApp and college groups basically. You can share it. You can join our doubt discussion group by scanning this QR code as well. So I will see you in the next video where I'm going to solve GATE CS 2023 previous year questions from another subject. Okay. So that's it from this video. We'll see you in the next video. Till then, take care. Bye-bye. Thank you.